So good morning students. So I welcome you in the lecture of linear integrated circuit. So we will see what exactly mean by linear circuit or linear integrated circuit. So we are using acronym as IC, that is nothing but the integrated circuit. So what exactly it means? It means the semiconductor material on which we are forming the transistors. Like if you are imaging the core i3 processor of Intel, so you will find near about 625 million transistor on this chip. 625 million number of transistor over this chip. So previously the first IC that is developed by the Intel is nothing but the IC 741. Okay, and this is the very commonly used IC. So in this IC integrated circuit, there are the registers are there, then the transistors are there, then lot of components are there on this single chip. You can imagine the single chips. You can having this processor like your biscuit, small size biscuit itself. So on that biscuit, we can say that on this wafer, semiconductor wafer, you can implement the resistor, capacitor, and transistors are fabricated over there. So the 74 IC it's very common IC over there. So the 741 IC was designed by Dave Fulger of Fairchild Semiconductor in 1968. So 1968 he has come with the solution, that is the integrated circuit, because we are using the component in the discrete manner, and the size is very high. Like your register, you can imagine that size. But if you are imagining the same thing in this one, if you are saying that 625 million transistor there, there is a big transistor over there. Okay, so he has come with the IC that is nothing but 741 by this guy Dave. So we will see the pin configuration, what exactly inside the 741 IC. 741 IC, what exactly it means. So in this 741, you will find this number of transistor A, 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So number of 18 number of transistors are there, and you will find the register 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 number of transistors and different diodes are there. So this is inside this IC 741 IC. So we'll see one by one the pin configuration. The first pin is nothing but my offset null. So I will tell you what exactly meant by offset null afterwards. Second pin is inverting input. So there are two inputs for this IC, that is nothing but the inverting input and non-inverting input. So in this case, the inverting is nothing but my input and output are inverted to each other, that is nothing but the reverse one. And the non-inverted means my output and input are the same phase, like my input is in phase like sine wave, and output is also in same phase like that. Okay, in inverting case, input and output are the out of phase. So out of phase and in phase I will tell you afterwards while dealing with the waveforms of inverting and non-inverting amplifier separately. The fourth and seventh pin are the supply pin. So we have to give the minus VCC supply to the fourth pin and plus VCC supply to the seventh pin. Okay, and one number pin and five number pin are offset null purpose, for offset null purpose. So input are how much? Inverting input and non-inverting. There are two inputs are there for this IC. So just output is remaining. So pin number 6 is my output. So from this end we are giving the output there. These are we are giving the output from this end. And pin number 8 is not at all connected. Pin number 8 is not at all connected. So this pin is not connected. So don't use that one. So types of 741 IC. So there are three types of IC. Are there the flat pin package? Okay, flat pin package here. The flat pin package is there. Again, same configuration, 10 pins, but this 10 and 9 are not connected over there. First is also not connected. If you are finding this in the flat pin, so this configuration is like this one. So you will find same IC in the metal can pack. So you have seen the metal can structure over there in circular manner over there. So this is 741 IC. So how to find out its pin configuration? By left hand anti-clockwise there, 1 2 3 4 5 6 7 and 8 pins are there. Okay, and notch over there, that is not connected over there. Then 14 pin DIP package is also there. DIP package, so inverting, non-inverting. Then minus V remaining pairs are not connected over there. So this is the 14 pin DIP package also there. Okay, so maximum rating we will see for this IC how much voltage and we can give and how much temperature it can withstand, like that one we will see. So supply voltage you can give plus or minus 18 volt. The maximum how much you can give 18 volt. Then internal power dissipation is how much 500 milliwatt. So it can withstand with 500 milliwatt power. Then differential input voltage is plus minus 30 volt. That is nothing but for inverting input and non-inverting input, whatever the differential voltage is there, that should be 30 volt. That is nothing but you can give one end at 15 and second end at minus 15. So differential voltage is of 30 volt. Okay. Then input voltage you can give maximum plus or minus 15 volt. So you can give not more than 15 volt, either plus voltage or minus voltage in the DC or as well as AC, because it will work on AC as well as DC. So offset voltage offset null, that is nothing but the plus or minus zero point 0.5 volts. So this what is offset null and all that we will see in detail while discussing the offset null concept. So operating temperature is from 0 to plus or plus 70 degrees Celsius. Okay, and for storage temperature range is of minus 50 to 150 degrees Celsius. So these are nothing but the different applications. Like for military purpose we can use this temperature, and for normal operating for commercial use we can use this temperature. This temperature I see over there. Then lead temperature is of 300 degrees Celsius over there, and output short circuit is of infinite. Yeah. So we'll discuss about next. We'll discuss about the block diagram of this 741 IC. So there are four blocks. There are four blocks. That is nothing but the input stage. Second is nothing but the intermediate stage. Third is nothing but my level shifting stage, and fourth is nothing but my output stage. These are the stages which we have to carry out in this particular IC, inside this particular IC. Okay, so what exactly meant by input stage? So input stage is nothing but I have to give the two inputs. Here in the IC you have seen there are two inputs. How many? Which are the inputs? Inverting input and non-inverting inputs are there. So this is again input. So input stage we have to give the input in these two. Either you can give to the non-inverting terminal. Non-inverting terminal is my plus terminal, and inverting terminal is my minus terminal. So we have to give the input to the input stage. Okay, input stage. So it will give you the gain, that is nothing but the high voltage gain over there. Okay, and it will give you a input resistance, that is nothing but the high input resistance over there. Okay, and this output of input stage is given to the intermediate stage. So we'll see what exactly mean by intermediate stage. So intermediate stage is nothing but it is having balance input, because it's having two inputs over there. So balance input you can say, and unbalanced output. So what exactly mean by balance input and balance output, that we can say. So for first stage there are two inputs, 1 and 2, and outputs are 2. So this is nothing but my balance stage, because number of inputs and number of outputs are same one. So we can say that balance input balance output stage. In the second stage, the intermediate stage is balance output but unbalanced input, balance input and unbalanced output over there. Okay, yeah. So this is given to the next stage, that is intermediate stage. So intermediate stage, this stage uses level transistor circuit. It makes DC voltages downward to zero with respect to ground. So it will reduces your output voltage with respect to ground. It is to zero. It is nothing but intermediate stage. In the level shifting stage, normally we are using the push-pull complementary symmetry amplifier over there. So it will give you the maximum power output. Okay, maximum power output is given to by the level shifting stage. So normal level shifting stage is used for to shift the output to the desired level. So what will happen in this case, due to the absence of balance output, the DC level, that is nothing but the zero level, is introduced over there. Ground level is introduced over there. So this reduce this level, we have to use the level shifting stage. So level shifting stage is used over there. And the last stage is nothing but my output stage. Here we are taking the output. So here your resistance must be a low, and it must be give you the output in case of power. Yeah. So what are the specification of this IC? So these are the very important terms We have to remember this term because in Viva these terms are commonly used. So what are the important specification? That is nothing but input offset voltage, input offset current, input bias current, slew rate, and CMRR. So that is nothing but the common mode rejection ratio. So we'll discuss one by one. The input offset voltage. So input offset voltage is nothing but it is the voltage that must be applied between the two input terminal of operational amplifier to null the output voltage. So what will happen? I will give you the example of this IC. So normally, if you are not giving any input to the operational amplifier, still you are getting the output. If you are not giving any kind of input to either inverting or non-inverting terminal, but still you are getting the output. In this case, what will happen if you have to nullify the voltage because you are getting some voltage, wave voltage. To reduce the voltage to the zero, what we are doing, we are connecting one 10 ohm, 10 kilo ohm resistor in between 1 and 5 pin, and we are changing its resistance to null the output voltage. To null the output voltage. So that is nothing but my input offset voltage over there. So I think you must get the concept what exactly meant by input offset voltage. So input offset current. So it is the algebraic difference of two input currents that flow into the inverting and non-inverting terminal of operational amplifier. So that is nothing but the whatever the difference in between the current flowing through the inverting terminal and non-inverting terminal, that is nothing but the input offset current over there. So third is nothing but my input bias current. So input bias current is nothing but it is the average of two input currents that flow in to the inverting terminal of operational amplifier. So, what exactly mean by bias current is nothing but the average current flowing through the inverting terminal. Average current flowing through. That is average is nothing but two inputs are there. So addition of 2 divided by 2 is nothing but my average. So input bias current. So input offset current is different thing. It is the difference, and input bias current is different. It is nothing but the average. Then slew rate, it is nothing but it is defined as maximum change of output voltage per unit time and expressed in voltage per microsecond. So that is nothing but the dV naught divided by with respect to dt. That is nothing but the maximum. Okay, that is nothing but the slew rate over there. Then CMRR. CMRR is nothing but the common mode rejection ratio. So common mode rejection ratio is nothing but the ratio generally defined as the ratio of differential voltage gain AD to the common mode voltage gain ACM. So that is nothing but the AD divided by ACM. So ACM is nothing but my common mode rejection ratio. That is nothing but the VOCM divided by VCM. So that this we will see in case of we will separately deal with the CMRR. Then we will see this concept in detail. That is nothing but the differential voltage gain to the common mode voltage gain. So this is nothing but my CMRR. Okay, so important features we'll see short circuit and overload protection is provided. Then low power consumption is there. Large CMRR and differential voltage range. Then no external frequency compensation is required. No latch up problem is there. So these are nothing but some features of this operational amplifier. So I think we have to stop over there. So I think you will like the lecture. So please like the session and share with your friends. So if you have any doubt, please comment in the comment section. So thank you very much for attending this lecture. Thank you.